Hello and welcome to Module 13 in our C language series. Today we're going to be discussing mathematical functions, but before we get on to that, let's first talk about the solution to our own version of STR-SPN. So going to code blocks now. I'm not sure you've done it, but if you haven't, it's okay. What we do is we just copy the entire STR-CSPN into a new file. I've called it STR-SPN. Right? And of course, you need to change the name of the function. Here you would have had my strcspn. Instead of that, it will be strspn. Similarly, you've changed the name here and here as well. Right? And within the function that we've defined, all we needed to do was just put in the exclamation mark to say if not strchr. Remember, strchr is looking for the first character that is a match. Right here, we're looking for the first character that does not match. If you just put in that exclamation mark, that should do it. So what I'm going to do now is, instead of running our version first, we'll run the standard library version. That's strspn, and let's see the result. You can see the first character from fruit that does not match any of the characters in str1 is p. And that's correct, isn't it? The first, if we go up to the strings or the arrays, the first character that does not match is p. Right? Now let's do one thing. Let's run our version and I'll comment out the standard library version. So now if we run this, you see we get the same result. Right? So that's our own version of STR-SPN. Now moving on to mathematical functions. Just an introduction before we get down to the functions themselves. The mathematical functions in the standard library include trigonometric functions, hyperbolic functions, exponential and logarithmic functions, miscellaneous functions, and all are included in a header file called math.h. Math.h also happens to include some macros that are important. Those include edom, erange, and hugeval. What these are, let's go and understand them through some code. And I've just written a few lines of code here. We're going to start with these two. We're using the function acos. We'll come to this function later in detail, but just for you to understand what those macros mean or what are their values. When we're using acos, the argument to acos has to be between -1 and 1. In this case, I'm giving it a value of 2.0. Right? And therefore, I'm going to end up with some error. So let's run this now. And you can see I get a -1.#ind00. This means it's indeterminate or undefined. Right? So what this amounts to is what is called a domain error. Because I've provided an argument that is outside the domain of the values that are allowed to be provided as arguments for this function. And then we have error number 33. Now, of course, I've said printf error number and then error no. But where is error no coming from? That's because I've included error number.h. Error number in error number.h is set to the number 33. And number 33 is the value for edom. So if we say here printf edom value, and it's an integer, %d, edom. Right, so you can see edom value is 33. So that's about edom. Remember that when there's a domain error, error number or ERR-NO is set to edom or the value of edom. Now let's move on to discussing another type of error, which is the range error. Right, so here we're finding out the log of a number, the number is 0. Right, so if I run this now, you get a negative 1 dot hashtag I and F standing for negative infinity. And the error number has changed this value now to 34. This comes from the eRange macro. So we say printf eRange value, and then we print out eRange. We run this. You see eRange has got the value 34, right? So that's about the range error. And now we'll see another instance of domain error. This time we're trying to calculate the square root using the square root function. But remember, this function does not or cannot calculate the square root of negative numbers. That moves into the arena of complex numbers, right? And it's not defined for that. And so when we run this, we get indeterminate again, or undefined. And you can see we get that domain error again, right? So I hope you understood EDOM, eRange. Now what's huge val? So when we have a range error, right, as in this case, so I'm going to comment this out now. When we run that, you saw we got an infinity, right? Now mark that value, because when I print out huge val, you will see that both are the same. Okay, so why is that a 0? Because I said percentage %d, it should be percentage %f. Okay, so now you will see it's the same, but you can see that's a positive infinity, right? So when is it positive and when is it negative? Let's just take a look at the summary of these errors and the interpretations. So we have here positive infinity when you have a larger positive number than can be stored in a double, and you have negative infinity when you have a larger negative number than can be stored in a double, right? And therefore we got that negative 1 dot hashtag INF when we try to find the log of 0. Negative 1 dot hashtag IND indeterminate, negative 1 dot hashtag IND 00, again indeterminate. NaN meaning not a number. This is something you may see also, or you could see something like this, but this is mostly with Linux. Now I hope you've understood the macros and their values as well as the meanings of these errors. Coming now to the first trigonometric function that we're going to discuss today is sine. As you can see from the prototype, this function returns a double and takes as argument a double as well. Returns the sine of the argument. The argument must be in radians. That's important. In a right triangle, the sine of an angle implies the length of the opposite side divided by the length of the hypotenuse. And so I could have a right triangle like this, right? And then if we wanted to find the sine of x, we would look at the opposite side, which is 26, the length of the opposite side, divided by the length of the hypotenuse. So divided by 30, we would get a value of 0.866. Similarly, we could find the sine of z, which is the angle with 30 degrees. Right? Then we would look at the opposite side, that's 15 divided by the hypotenuse, and we would get the result 0.500. How do we put this into code? So let's now go to code blocks and we'll start a new file. Hashtag include stdio.h, and then hashtag include stdlib.h, and hashtag include, of course, math.h int main, and we'll just have one double type variable, call that rad for radians. Now, when we are doing the calculation through our code in C, we cannot use the same arithmetic operation that we saw there on that slide. What we need to do is take the angle, convert that angle into radians, and provide that to the sine function as argument. So we'll do just that. We'll say rad equal to, for the 30-degree angle, 30 into pi, 3.14 divided by 180, will convert that into radians. And once we've done that, we can just print out the sign. So printf sine of 30-degree angle is percentage 3.3f. So 3 digits before the decimal and 3 after the decimal. And then comma, call the function sine, passing in the argument, which is rad. So now if we run this, we should see the sign for the 30-degree angle. That's 0.500. And now we can do the same for the 60-degree angle. So I'm just going to copy this code. And we can change what needs to be changed. So 60 here and in the message as well. Right, so now we should have sign for both angles, 30 and 60. And that's the same as you saw on the slide. Right, the results, I mean. So now moving on to acosine or arcsine. That's the inverse of sine. From the prototype, you can see this function returns a double and takes as argument a double as well. Returns the arcsine of argument. The argument must be in the range -1 to 1. Otherwise, we have a domain error, just as we saw for arc cosine. We have the triangle here, and we need to find the sine first and provide that result to arcsine to get the measurement of the angle. So now let's go back to code blocks. We have the sine here. We'll use that to find the arcsine for both these angles. So here we'd say arcsine, and of course we need to declare arcsine here as being of double types. Arcsine equal to acosine is the function name for arcsine, and pass in sine of rad. Right? Now the result will be in radians. We're going to convert that back to degrees. And so what we'll do is we'll say printf arcsine is, and then percentage f, I'm going to leave it at that, \n, comma. Now what we need to do, like I said, is convert to degrees. So arcsine into 180 divided by pi. To convert to radians, it's 3.14 pi divided by 180. To convert back to degrees, it's 180 divided by pi. Right? And we can do the same for this one. Right? So again here, arcsines, we can just copy those two lines of code actually. And put those here as well. So now if we run this, you can see we get 30.000 as arcsine for this angle, and then of course 60 degrees, right? But we don't want to see that 0.00. So what we do is we just say percentage 2.0f, right? Okay, and there we have 30 and 60. So I hope sine and arcsine is clear. Any questions you can post in the comments. Moving on to cos. From the prototype, you can see this function returns a double, taking as argument a double as well, returns the cosine of the argument. The value of the argument must be in radians again. Remember, the cos in a right triangle is the length of the adjacent side divided by the hypotenuse. And so if we have a right triangle like this, and if we want to find cos of A, which has the angle of 69 degrees, then you will look at the adjacent, which is AB, has a length 10 divided by 27.4 hypotenuse, and you get the result 0.365. Similarly, cos of C, which has angle 21 degrees, right? You take the adjacent 25.5 divided by hypotenuse and you would get 0.931. Let's put this into code now. So going back to the same program, and we just put a comment here saying cosine. And you can put a comment here saying sine, right? Now for cosine, again we say rad equal to 69 is the angle into 3.14, that's pi divided by 180, right? And then printf, comma, cos is the name of the function, and we pass in rad, which is in radians now, right? We can do the same for the angle with 21 degrees. So 21 into 3.14 divided by 180, and then printf. So we can just copy that line of code here. And of course, change this to 21. So now if we run this, we should have sine and cos as well as arcsine. And you can see we've got cosine of 69 degree angle is 0.359 and of 21 degree angle is 0.934, which is slightly different from what we saw on the slide, right? We've got 359 here and 934. But you will see when we discuss our cosine, we do get the same measurement of these angles in degrees, right? We will get back 69 and 21 using the cosine values that we got earlier. So now talking about the arc cosine, we have the prototype here. You can see that the function returns a double and takes as argument a double as well. Returns the arc cosine of the argument. The argument must be in the range -1 to 1. And if you have a triangle like this, then cos of C would be 24.2. That's adjacent upon hypotenuse, which is 28. And then you get the result. And then you provide that result to calculate arc cosine. Right? So now let's go back to the code and calculate arc cosine for both these. And so we'll say here arc cosine or arc cos equal to a cos and provide as argument cos of rad. And of course we've got to put in here the variable as well. So arc cos, right? And then we can print that out, but we need to convert it to degrees again. So printf arc cos is, and then percentage 2.0 f, and then comma arc cos into 180 divided by pi, right? And similarly for the next one. So that's here, right? So now if we run this, we will get those angles back, and you see we get 69 and 21, right? Okay, so I hope that's clear. Moving on, we come to tangent, and you can see from the prototype this function takes as argument a double and returns a double as well, returns a tangent of the argument. The value of the argument must be in radians again. And tan in a right triangle is length of the opposite side upon the adjacent side, or divided by adjacent side. And if you have a triangle like this, then calculating the tan of C would be opposite, which is 15, divided by adjacent, which is 26. You would get 0.577. And tan of A, which is the angle with 60 degrees, you would look at the opposite side, which is 26, and divide that by the adjacent, which is 15, and you would get the result. Now let's go and put this into code. So to do that, we need to go back to code blocks to the same program, and here we'll put in a comment saying tan and rad equal to 30 into, now you could also put this in brackets, 3.14 divided by 180, but it won't make a difference. And then printf tan of 30-degree angle is right, and then comma, and we call the function, so tan of rad. Similarly, for the 60-degree angle, so that's equal to 60 into 3.14, that's pi divided by 180, right? And then of course we can just copy this line of code and change this to 60. Right, so now if we run this, you can see the same results, 0.577, 1.730, right? Now, moving on, you can see there's a very slight difference, but that's not going to, give us a different angle measurement when we're talking about a tan or arctangent. So arctangent, again from the prototype, you can see taking as argument a double and returning a double as well, returns the arctangent of the argument. The value returned is between minus or negative pi by 2 and pi by 2. So we have a triangle like this. We calculate tan, and then we provide the result to a tan or arctangent, and we arrive at the angle measurement. So let's now go back to code blocks. Let me just close this window. Now we can go back to code blocks, and we put in the code for calculating a tan. Right, so here we will say arctan equal to a tan, and provide in the argument that will be tan of rad, right? And again, we've got to convert that result to degrees, because remember that will be in radians. So printf arctan percentage 2.0f, comma, arctan into 180 divided by pi, right? And similarly for the next angle, so I'm just going to copy these two lines now, and we can put them here, right? Now, of course, we need to have our arctan specified here, so comma arctan. Now if we run this, you can see that we've arrived back at the angle measurement using arctan. Right, so I hope this is clear. Coming now to atan 2. So there's arctan and there's arctan 2. Again, you can see from the prototype, this function returns a double, but takes as arguments two doubles. y and x. Now these will be coordinates. This function returns the arctangent of y divided by x, uses a sign of arguments to compute the quadrant of the return value. The value returned is between negative pi and positive pi. And so when we talk about quadrants, we're talking about these. So the first quadrant you can see has positive x and positive y. That's everything positive. The next quadrant, that's the one on the left, has got negative x and positive y. The third quadrant has got negative x and negative y. And the fourth quadrant has got positive x and negative y. Important to note, in this function, it takes the y coordinate first and then the x. So now let's go back to code blocks. And we'll include code to calculate the arctangent. I'm just going to put in a comment here, say atan 2. We're going to look at arctangent 2 for positive 1 being y coordinate and positive 1 again being x coordinate, and then for negative 1 being y coordinate and negative 1 being x coordinate. But before we do that, I want to show you how atan would deal with something like that and what values we would get if we use atan. Right, so I'm going to say here arctan equal to atan of, and we printf comma arctan into 180 divided by 3.14. Right, so let's run this. And what I'll do is I will just comment out the rest of the code so that we can focus just on that. So you can see we get this 45-degree angle, right? Now, if I change this to -1, and I run this, again you get 45, and it cannot be, right? So therefore we use arctangent 2. If I use arctangent 2 now, so I say here arctan 2 equal to atan 2 of 1 comma 1, right? And then I print the result, and we do the same for -1. And just change these to -1 for y and -1 for x. And of course, arctan 2 has to be declared here. So now we run this. Okay, there's some mistake there because I haven't converted this to degrees into 180 divided by pi. Right, let's do the same here. So you can see we get for 1, that's positive 1 y and positive 1 x coordinate, we get 45, yes. But when we provide -1, and of course I should have changed this message, which I didn't. So let me just run that again. So for -1, it is -135. Now, in terms of the angle itself, 45 is fine. But -135, we would want to represent more in relation to 360, right? So to do that, we need to use a formula. So what we can do here is we can have a separate variable. I'm going to call that AT2 res or result. And here, instead of printing out this result as well as this one, we say here AT2 result equal to, and we're going to use a ternary operator. So arctan 2, if that is greater than 0, then we'll use the value of arctan 2. Otherwise, we will use a formula 2 into 3.14, that's 2 pi, right? Plus arctan 2, right? And this whole thing we will multiply 360, right? So that's multiplied by 360 divided by 2 pi. So 2 into 3.14. And then what we can do is we can just print out A2 results. So printf, and we can do the same thing for -1. We can just copy this down and paste it here. So now if we run this, you see we get 45 and 225, right? This ends our session for today. In the next session, we'll discuss more mathematical functions. Till then, take care, stay safe. Bye.